This video is about the single most transformative technology for the building industry in history. Hello, I'm Richard Swett, CEO of Climate Prosperity Enterprise Solutions. We have partnered with ASCI Limited to bring to owners, designers, and general contractors a new virtual technology tool that will make their lives easier and help them to save time and money on their projects. It's driven by a construction technology that has just recently been vastly improved. Let me tell you about it. The architecture, engineering, and construction industry made up more than 10% of the world's GDP in 2011 and is expected to grow much faster than the world economy this decade. To do so productively, the industry must use the best information technology available. By carefully managing collaboration with visual information modeling, or VIM, builders can save money, time, and wasted energy. In 2011, the budget for a Kaiser hospital in San Francisco dropped to $750 million from $950 million by using VIM. Nevertheless, the construction industry has been slow at adopting modern automation technologies. Building information models, or BIM, show how the construction industry is starting to utilize the computer to transform itself, as manufacturing, finance, and distribution industries have already successfully done. This 2012 book is a primer for building owners, written with major contributions by our partner Errol Walford, who has dedicated his career to creating computer models and databases that make the construction industry more efficient. The transformation from pencil and paper to the computer information age was far more profound than just being a different way of producing construction documents. In the past decade, we have gone from two-dimensional AutoCAD drawings to three-dimensional Revit space in the computer. And now, with VIM, we can leverage building databases, connect to the internet, and consequently save time, money, and energy for the owner. When the military used this technology, they got it. Their aviation technology allowed companies like Boeing to build and fly jets virtually in the computer. Using VIM in the new 787, Boeing has continued to make savings in weight, mileage, and jet fuel. In the last 40 years, productivity has been very dramatic in all industries but one, construction, where productivity has hardly improved at all. The AEC industry is still stuck with software that produces images which are static and slow to download or animate, which disconnect the architectural and engineering drawings, which are disconnected from building object, pricing, and energy databases, which are difficult for more than two people to analyze at once, and which produce files that are too big to send easily around the internet. VimTrek is an interactive 3D representation of the Revit design powered by a gaming engine, where seating is unlimited, the architectural and engineering files are seamlessly merged, and where access is easy by PC, Mac, or the web. Now, the owner, architect, engineer, or whoever plays a role in the design process can virtually walk through the building, make notes about any one of the thousands of objects there, provide his reasons for change, have a conversation with other experts, collaborate to a decision, and have the model operator insert the changes in the model. It takes only a week or so to train an architect or engineer how to operate the model. VIM is very friendly to navigate. The owner and hundreds of others can collaborate to select the landscape, the infrastructure, the energy facilities, the materials, and all the thousands of objects that are useful in the building by precise dimensions, by competitive cost, by energy use, and by environmental impact. They can walk through the facility to make final decisions in the model's punch list. Not a thing has been built yet, but the building has passed its flight test. The model can take the owner right from the hospital room discussions to spreadsheet consequences for cost, availability, procurement, and logistics for just-in-time delivery of the product. Here you see the building's cost being instantly estimated by the RS Means database, based on the quantity takeoff of the materials and objects contained within the model. Virtualization has taken the mystery out of construction. Counting objects manually can absorb 10% of a project budget. Change orders on the site can lead to overruns, delays, and even bankruptcy. By utilizing technology's virtualization, you can achieve low procurement costs, take full advantage of prefabrication, eliminate surprises, maximize cost savings, sequence the construction process perfectly, and deliver the project on time, or maybe early. Most of the world's buildings were constructed when energy was cheap and the costs of pollution were unknown, so architects didn't even consider it. That's why buildings use almost half of all the energy consumed on the planet. Energy analysis of a VIM model can be derived using state-of-the-art software called Integrated Environmental Solutions, or IES. IES analyzes the performance of your building and provides estimates on electricity usage, heating fuel usage, water consumption, renewable energy generation, and carbon credits earned. Maximizing clean energy generation in the model can save up to 40% of the expected energy costs of operations, which is about what Bank of America achieved with its recently constructed building in Manhattan. The largest energy consumers are the HVAC systems and the lighting systems in most buildings. To make them more efficient, VIM easily merges the engineering and architectural documents into one interactive electronic file. Let me show you how a total collaboration works. In a walkthrough of the model, a conflict or error is discovered. Through the collaboration process, the right solution is found and is placed in the virtual punch list of the model. Without this virtual correction, conflicts and errors would occur on the site, resulting in costly change orders, project delays, and cost overruns. The model is built from A to Z with total collaboration using every brain and database that's needed. Here's an example of how VIM works in a hospital. This virtual hospital room and designed for Istanbul, Turkey, is being viewed by the medical consultants in California, project managers in UAE and Istanbul, architects and engineers in the US and the UAE. They can make notes, changes, analysis, and decisions right there in the virtual room. This changes everything. Collaboration is not constrained by time, space, or language. Collaboration is virtual and instantaneous. The enterprise solution drives the communications process of the model. It guarantees that all the people with critical knowledge are using the model at the right time. Collaboration is the key to an efficient construction process and thus is the key to savings in the design, construction, and operations of the building. In operations, the enterprise solution integrates people into the model. The resulting metrics show the productivity, cost-effectiveness, satisfaction, and sustainability of the integrated model, which include the built and human environments. With visualization and collaboration technologies, a building model operator can modify, move, produce, price, analyze, manage, store, or replace any object in the facility, no matter how big or small. He can navigate in or out, up or down, backwards or forwards, as if he is water, air, electricity, or people navigating within the building. He can do this via the web anytime with the owners, architects, engineers, financiers, contractors, or anyone the owner chooses, so everybody knows everything when they need to know it. The best construction is best done virtually. Thank you for listening to us. I hope you enjoyed our virtual video tour. Our partners from ASCI will now listen to your views about how this most advanced construction technology can be applied in your business.